So for lecture 6.3, we're going to talk about torque. Next, let's talk about the conditions for equilibrium. Equilibrium is the state where there is a balance in forces on both sides. So the line of action of a force is an imaginary line. It's only an imaginary line, extended indefinitely along the vector in both directions. To have equilibrium, of course, we need to have both forces. I mean, equal forces on both directions, because if not, it will not satisfy the definition of equilibrium. Let us now define moment arm. Moment arm is the perpendicular distance. Perpendicular distance from the axis of the rotation to the line of action of a force. So that's the perpendicular distance. Next, let us now talk about torque. Torque is defined as the tendency to produce a change in rotational motion. So we are talking change in here. The formula in order to solve for the torque is equal to R multiplied by F, or R multiplied by F multiplied by sine theta, where T is torque, which has a unit of Newton meter, R for the moment of arm, which has a unit of meter, force is represented by letter F, capital F, which has a unit of N. Next. So the following are the problem-solving strategies for you to solve easily torque problems. So first, read the problem and then draw and label a figure as always. Number 2, construct a free body diagram showing all forces, distance, and axis of rotation. So just like with number 1, it's like you're just putting labels. We do this for you to easily solve the problem, because you know the forces, distance, and axis of rotation, which are useful in solving torque problem. Number 3, extend the lines of action of each force using dotted lines for better free body diagram. Number 4, draw a label. Draw and label the moment arms for each force, since we will be needing moment arms in solving for the torque. Next, calculate the moment arms if necessary. Number 6, calculate the torques due to each force independent of other forces. Make sure to affix the proper sign. Counterclockwise is positive, clockwise is negative. So calculate the torques due to each force independent. So independent meaning each forces. Next, number 7, the resultant torque is the algebraic sum of the torques to each force. So after solving independently for the torques, in order to solve for the resultant torque, as usual, resultant means it is the algebraic sum. So add all the independent torques you've solved in order to solve for the resultant torque.
A small ball of mass 0.75 kilograms is attached to one end of a 1.25 meters long massless rod, and the other end of the rod is hung from a pivot. So when the resulting pendulum is 30 degrees from the vertical, what is the magnitude of the gravitational torque calculated about the pivot? So ang gagawin lang natin dito is we use the formula for torque. So alam naman natin that torque is the cross product of your moment arm or level arm, is the cross product of your moment arm or lever arm and your force. So yan. So Kapag kinonvert natin yan, ang cross product niyan is also equivalent to RF sine theta. Ito lang yung gagamitin natin and isa-substitute na natin yung mga values na binigay sa atin. So yung moment arm natin is 1.25 meters. So sulat natin yan. That is the value of your R. So 1.25 meters. So 0.75 kilograms, that is the mass. Ang hinahanap natin is yung force. And the force that we will use is the force of the weight. So ang gagawin natin is 0.75 kilograms times 9.8 meters per second squared. So kukunin natin yung weight ng small ball na yan. So yan. So this is your R, this is your F, and your so yan. So this is your R, this is your F, and your sine is 30 since yun yung given angle. So yan. So multiply them all and you will get 4.59 Newton meter as your final answer ng torque para sa kapag ganyan mga klaseng problems lang. Kapag binigay naman sa atin lahat ng mga necessary values and ang hinahanap lang naman is gravitational torque. So it is just basic application ng formula. And for problem 7, a particle moves through an XYZ coordinate system while a force acts on the particle. When the particle has the position vector given by R equals 2i minus 3j plus 2k, the force is given by F equals fxi plus 7j 6k. And the corresponding torque about the origin is tau is equals to 4 Newton meter I plus 2 Newton meter J minus 1 Newton meter K. So, ang hinahanap is yung value ng F sub x. So, ito yung hinahanap natin. F sub x. So, ito yung hinahanap natin. So, if we recall again, alam natin na ang formula ng torque or tau is equals to your position vector, so R, times the force, your force acting on the particle. So yan, so ito yung isa pang interpretation ng formula na. Alam natin na yung cross product ay pwede rin nating isolve through the determinant of a matrix. So, yun yung gagamitin natin to solve for this problem. So, una, isulat muna natin yung mga binigay sa atin. So, what is our position vector? So, sulat natin siya atin. So, what is our position vector? So, susulat natin siya in vector notation. So, that is 2, negative 3, and positive 2. Tapos, binigay sa atin yung value noong force that is, ay nawawala, Fx, then 7, 6. And our value for torque is given by 4, 2, negative 1. So, ibig sabihin, kapag daw kin-cross product natin itong 2, negative 3, 2 with Fx, 7, and negative 6, dapat ang lalabas is 4, 2, and negative 1. So ngayon mag-drawing na tayo ng isang matrix. So, we draw a matrix here. Ilagay natin dito yung ijk. Yan. So, we have again 2. Then we have the fx. Then 2 and negative 6. Ayan. So, anong gagawin natin ngayon dito? So, simply, we perform the normal process of a cross product. So, for example, para makuha natin yung value ng 4, so i-cross natin yung j. So, yung j and k. So, negative 3 and negative 6, that will give us 18. So, yan. So, and 7 times 2 will give us 14. So tama. So, tama yung nakuha natin na 18 minus 14, which is yun yung gagawin natin para makuha natin yung cross product. So, tama lang na yung y coordinate or x coordinate is equal to 4. So, tama. So, proceed tayo ngayon sa next. So, ngayon, for the J coordinate, so we have 2. So, i-cross naman natin ngayon is yung I and K rows or columns. So, 2 times negative 6, so will give us minus 2fx. Ay, sorry, baliktad pala. So, uunahin pala muna natin yung unahin pala muna natin itong 2fx. Unahin pala muna natin itong 2fx. So 2fx, so 2fx, then minus 2 times negative 6, that is negative 12. So that will give us positive 12. So 2fx, 2fx plus 12 is equal to 2. So yan. So ito. And lastly, for the k coordinate, which is dapat equal to negative 1. So i-cross naman natin yung I and j columns. So we have 2 times 7, that is 14, and negative 3 times fx will give us minus negative 3fx. So that will become 3 plus 3fx. Ayan. So given na ngayon yung values ng ano natin, given na ngayon yung values um, ng mga cross product natin per component. So ngayon, pwede mo namang gawin dito na is mamili ka na lang ng equation na gusto mong gamitin to find the value of your fx. So pwede mo tong gamitin yung 2 equals to fx plus 12, or yung negative 1 is equals to 14 plus 3fx. Either way, parehas naman yung makukuha mong sagot. So gamitin natin itong negative 1. So negative 1 is equals to 14 plus 3fx. So i-transpose natin. So this will become 1 minus negative 1 minus 14 is equals to 3fx. And that will become 3fx. And then we divide both equations by 3, and we get that fx is equals to negative 5. Therefore, the value of your I component of the force is or should be equal to negative 5. So, the equation 5. So, the equation or our unit vector notation for the force should be equal to negative 5i plus 7j minus 6k. So, ayun. So, nasundan po ba yung Thank you for listening. I hope you learned something today, and see you on the next discussion video.